Okay, welcome back. Today we are happy to have you. I believe you enjoyed the first part of the video. We are still on the training on how to design our open world staircase. Here we have design part 1. If you have missed it, you didn't view part 1, you follow part 1. I would recommend you follow the link in this particular video and you see part 1 where you would follow up before you can really understand what you are doing here. In that last week, we were able to automate this. This is a staircase from the input. Here we show us all the code, all the formatting, and then we arrived at a point where we design the last flight, which is flight 2. And today we want to look at how to design how to do deflection check. As I told you the other day, that deflection is as important as the design, because if the building is okay but fails in deflection, that means the overall building is failed. There is no two ways about it. So before wasting much of our time, today is going to be a very short part, and we are going to be done with it. So I require you stay tuned, and then see how we can follow up. I have some interesting things to show us. I believe you are going to learn a good number of ways to automate Excel. And when you have a complex formula like deflection formula, how are you going to do it? So I'm going to show us how we can break it down and then enter without having any error. So let's get started. Now I've done some setting for us. Now this is a deflection formula where we have to first of all find the modification factor. There is a modification factor. Inside modification factor, we have a different formula inside it, and then we have this. So I'm going to explain this and then show us how we can enter this in Excel without mixing up data. Now, this is how it is. Inside modification factor, we have this numerator where we have FS, and FS is what design service stress of tension. Alright, tension reinforcement, and it's given by this formula. So how are we going to do it, and how do we enter it in Excel? Do we enter in one line also? Don't worry, stay tuned. I'm going to show us how you can break my complex formula down to a point that you can enter it effectively in your Excel. So let's see how we have put this up already, where we have FS. For this formula, we are going to do this separately. FS, since it has a separate formula, and also do this separately since it also has a separate formula. At the end, bring it together, find the numerator, find the denominator, and then find the denominator, and then add to this, and then we have our answer. Then if it is less than 2, I'm going to show us how we comparing effectively. If it is less than or equals to 2, now we take that value, but if it is more than 2, we take 2. Modification, this one over lambda b is a percentage of moment redistributed. Code is we use 1, is normally reduced to unity. So that is what we are going to use in this code. Remember, we are still using designed a booklet from our able engineer, Victor Jenoga, and today we are going to do some checks on that and see how our design has been effective. So without wasting much time, let's start entering the formula. Now the first one is FS 5 FY. Area FY is the characteristic strength of steel times the area of steel required. Okay, so divided by 8, area times the area of steel provided. So which of the span are we going to do this? Which of the area we're looking at? Remember, in the staircase, open world staircase, we have 3 spans where we have span 1, 2, and 3, and we are going to use critical span for this modification, for this deflection. We are checking the deflection mostly in span 2, because if span 2 fails in deflection, that means all other span can also fail. Okay, so if span 2 is saved, we are sure that our design is also saved as well. So we are going to use span 2. So let us enter the formula. Remember, as we are entering formula in Excel, always call Excel formula of functions starting with equals to. So 5 times the steel strength, characteristic strength of steel, right there, times what? The area of steel required. Remember, we are entering FS, area of steel required for span 2. The span we are calculating, span 2, area of steel required is this. Okay, we close the bracket, divided by open the bracket. We are starting with 8 times the area of steel provided at that point is this. We close the bracket, and then I remember 1 over lambda b is omega b is mostly reduced to unity, so can multiply by 1 or so. We leave it like that. So we enter, okay, before then I have to open a bracket here. So I click on OK. Now this is the formula. Now we enter the formula. Now we are going to enter the numerator. Numerator is this. So we are going to see equals to 477 minus our rs equals to. We are through with that. The next one is m over bd square. Okay, so our m is what? Equals to, remember, we are going to open a bracket. Open bracket. We are using this moment. This times 10 raised to the power of 6. Remember, we have to convert it. Divided by what? bd. Divided by bd square. What is our b? B is 1 meter. We have it there. And our d, the effective depth is this. So I square it. Right, close the bracket and enter. Okay, we are through with m over bd square. We are going to enter our denominator. This is our denominator. 120 times 120 into 0.9 times m over bd square. Alright, so we are going to enter this. We say equals to 120 of times bracket 0.9 plus this. Close the bracket and enter. Alright. Then the next thing is for us to simplify this. That means that will be what? This over this plus this. Okay. So we can say equals to 0.55 plus open bracket. I'll now say what? Numerator divided by the denominator, open bracket and enter. Okay, we have 1.55 as our modification factor. So we are through with our modification factor. So where do we put our modification factor? Modification factor is equals to this. Now, how do we know if it is more than 120? If we are giving out this booklet, nobody will have to like check. So for us to do, we are going to use equals to minimum. The minimum between what? Minimum min is a function. Minimum between what? This, comma 2. Close the bracket and enter. Now this will always find the minimum value. Let us put 3 and 4. Now I put that formula equals to minimum this between this and that is 3. If I change this to 10 or 19, it takes the minimum, which is 4. If I change this to 50, it takes the minimum, which is 19. So it always play along. Once you put that formula, it makes it easy. Okay, so that is how it works. So we have now checked, we have entered this formula. Now how can we enter this formula in one line? Can we try that? Okay, at the end of this lesson we are going to look at that. Let's move forward. Stay tuned to the end. I'm going to show you how you can enter this formula in one line of Excel code. Okay, now since we are through with that, let's get rid of this. The next thing we want to check deflection. Now the formula to find deflection according to BS 8110 is 100 S required over BD. So we are going to enter this one direct. So this will be equals to deflection in slab or staircases. So we are going to have 100 times AS required. This we are still using the critical, divided by BD. Our B is the weight and the D, and D is effective depth. Close the bracket and enter. So that is 0.16. And the next thing is for us to look for required effective depth. So let us look at the formula. Okay, the required effective depth. The formula of finding required effective depth is 1000 times the span over 20 times modification factor according to the code. This will be equals to the effective depth is what? 1000 times what is the span? Our span is this, the critical span, divided by open bracket 20 times the modification factor, this. Close the bracket. Please let me explain something here. You've seen me always opening bracket whenever or putting my denominator in parentheses whenever I'm entering a fraction, formula that involves fraction. It is very, very sensitive. Like we said, Excel obeys BODMAS. If you know BODMAS or order of operation as the case may be, you can call it BODMAS or order of operation. So if you don't put it in parentheses, Excel will take the very first, especially when it has to do with the addition, subtraction, that is the function and the denominator has to do with addition, subtraction and otherwise. But if it is multiplication, fine, it will still compute it accurately. But when it has to do with the addition, subtraction and so on, you have to put the entire thing, the entire denominator in a parenthesis to avoid mix-up in the calculation. Because if you don't put it right, if they're going to give you what you give him, and Excel will not tell you how this formula is wrong, that is not the best way. Excel can only predict to some extent, so you have to be conversant with the way math is being done. It is still Excel still obeys mathematical rules, the one we were taught from nursery, primary and so on to this stage. So there's nothing much. That is why I'm doing that. So let me put this. Okay. So that is the required effective depth. Now we are through with that. Now we want to check deflection. What is the deflection? If this required effective depth is more than the effective depth used, that means it's not satisfied. What do we mean? If this is more than this, that means not satisfied. As this one is more than this, the equation is not satisfied. That is why you see this formula. If, let me put this formula again, equals to, if function, if this is more than this, comma, what will happen? Open my quotation. Remember, I told us for us to combine text and then this thing, you have to put, if you want to call out a text or any write-up in Excel, you have to put it in double quotation. Okay, this is deflection not satisfied, else deflection satisfied. Remember, I still have to put it in quotation. Now what am I doing? Or what I'm saying is this, if this is greater than this, that means deflection is not satisfied. But if this is less than this, that means deflection is satisfied. That is how we write if function. At the end, we close the parenthesis and click OK. That is why you are seeing deflection not satisfied. If you want to know, let me quickly reduce the depth. Effective depth has to do with the waist of the stage. So if I should reduce the waist of the slab to, let's say, 100, we can come back and check. Okay, let's look at, okay, we use this waist, not the other waist. So if we change this to 100, you see everything mess up. So we change this to 120. Deflection not satisfied because this is 250. Deflection, required effective depth here is 250, but here effective depth is 87, so it's not satisfied. So we have to either increase the depth. When it happens like that, if you are doing manual calculation, you have to start afresh using a different waist. 150, still not satisfied. We can as well reduce the diameter of, when you reduce the diameter, it's not satisfied. This particular flight mass provision not okay, because the area required is more than the area provided. So if we use Y12 in this case, it's not going to work. That's our provision not okay. That is why this one flag off to be red. So we have to leave this as 16. Okay, why 16? Because the span is 1.2, and it's how many steps? We have 6 steps in that place. So the another thing that always guide is, apart from the architect predefining how you work, and you know that in structural design is how you can make some modification. Always try to make the span of the steps, reduce the number of steps at the middle span. That is flight 2. You can have lesser steps there, it will be better and safer for you, because the load there will reduce effectively. That is why most design you see they reduce the depth. So at that point I have to increase this waist. 150 will not work. Let me take 175. 175 work perfectly. So the minimum waist that can be used is 175 in this case for the design to pass both in provision and the satisfy the deflection as well. So okay, So that is how we can impute a deflection. Now let's see how we can enter this multiplication factor in one line. This is like the last of most of us. So I'm going to enter it here, equals to, remember I'm going to open bracket, equals to 0.55 plus, going to open three brackets, 477 minus, going to open another three brackets, another two brackets to take care of this fy. We are entering fy now. So we are saying 5 times the fy, this is the fy, times the as required, this is close, divided by, open another bracket, is 8 times what a is provided, is close the bracket, close the second one. We are through with that, and then close. Okay, we have closed our bracket to this point now. So now the next one will be for us to divide. When we divide with what? Open bracket. Open bracket. We have what? Open another bracket. Okay. We have 120 times, we open another bracket, and we have 0.9 plus, we open another bracket, open two brackets. Our m is what? This is our m, times 10 raised to power of 6. We close the bracket, divided by BD. Our B is this, times our D is this square. We close the second bracket, close the third bracket, close the fourth bracket. Now we are through with entry. We are going to close these brackets and then close the last one and enter. That gives us what? 0.55 to 2 decimal places. Is it supposed to be 0.55? Okay, let us cross check. We've missed one parenthesis. I hope let us look at the code and see how we can rectify it. I deliberately allow this to happen at times so that you know it's not always that you get it right. When you make a mistake, being able to trace it will help us to really improve in our Excel skills and also prevent the repetition of what happened. What I'm doing now, I'm trying to trace it one by one from the bracket I opened to the one I closed and the one I didn't close. I believe it will help us. So just hold on with me and very soon we will rectify. Thank you. Okay, we have rectified. I didn't know that thing I told us. I didn't include this in the bracket, so I'm just include bracket here to rectify that. So if you look at this, is one line, this is a multiple line. We break it down so our code is correct. One thing is very particular in Excel. Once you understand what you are doing, you won't have issues. If you see the way I enter this, enter with one line, we have our answer. But because I want us to understand how we can enter it, I break it down part by part. When you have a complex formula to enter in Excel, just like a calculation, when you are calculating, you have to first of all calculate fs, calculate m over b d squared. Before you now put fs to this, you get the answer, get this, put to this, get the answer, then multiply by this, divide this by this, and then add to this. The same thing we are doing here. You can break it down part by part if you are not conversant with a complex formula in Excel. So that is why I'm doing this. Okay, now that we are through with the deflection and There's also important part of design I want us to see, the trick I normally use so that I don't have to screw around here anytime I design to screw and check it. Does this one bad like this one? That is not bad, there is not okay. How do I do it? Like this one showing it here. So I want to see how to show also that you can also apply it in your design. It helps calling out some important parts of your design, important checks so that you know that what you are doing is actually correct. You don't have to go through it one-on-one, like whenever you have a complex design like the slab design. I'm going to show us how we can do that later. So let's see how we can do this. I'm going to show us in span 1. Span 1 is this, where we you look at this. If I change this to 10 and increase this to, let's say, 15 steps, I'm going to say provision is not okay. So how do we put that so that it will tell us, look at it, the provision is not okay? You can detect it here without having to go through these things to check whether it's okay. So that is what we are going to do now. Now let's see, I'm going to select it. When you click on that, we are using two functions, if function and all function, because we are comparing two scenarios here where the area of steel required is more than the area of steel provided. Definitely something is wrong. If you are familiar with design, you know that it's always advisable, even from the code, for you to design the area of steel provided should be slightly above the area of steel required. This is kind of a safety measure so that whatsoever happens on site, you can still be within the frame of safe design. Now, we don't want any area, we don't want the area of steel required more than the area of steel provided. We want at all times the area of steel provided to be more than the area of steel required. And at the same time, we don't want the area of steel provided to be equal to the area of steel required. We don't provide the exact. That is another thing we are checking. That is why we are using these two functions, or if and all functions. Like now, if you look at this, you are going to see this is logical text. It highlighted our logical text. You are saying if or this. If the area of steel required is more than the area of steel provided, or if the area of steel required is equals to the area of steel provided, what should happen? We now look at the value. Now that value is what? Look at this. What is the true value? If this happens, what should happen? Provision should bring out the text. Provision for flight 1 is not okay. But if it is the other way around, this is the next value if not true. If this expression is not true, it should bring out this one. So that is how that is being achieved. Now, don't worry, at the end of the day, I'm going to put this in workbook, a link to this workbook where you can download it and make use of it for yourself. Now, the next thing is how do we make it to highlight? Now, we used this is called conditional formatting. From conditional formatting, you can put anything. You condition an outcome based on the outcome. You condition a cell in an Excel based on the outcome of the output of that particular cell. So now we are going to, for us to achieve this, you click from home, conditional formatting. From conditional formatting, you see other thing. You click on highlight cell row. If you bring up this drop down, you come to text that contain. We are looking for a text that contain what you now copy this first and put this text and put here. So it will always look for that text. If this particular cell contains this particular provision, it can be a whole text, it can be a part of this. Like now, you can choose to say it's not okay. You can just put it's not okay. It will look for anytime it says it's not okay in the expression that appears in this text, it will highlight it whatever we format. So how you format it, you have predefined formats here, or you can also customize your own here, where you select on customize and you click to put the font size, the font. When you finish, you can put the border, define the type of border, and then the field. How do you want it to look like? I'm not going to do that because we have that already. The only thing I will show us, how can you edit that. You can, for conditional formatting, come to the last, you see manage rule, you click on it for yourself. This is our conditional formatting that we put in that particular. So when you click on edit, you are going to see these are the formatting. You can click on format and you can change any of these, and then you click OK. You can see, look at it here, format only cell width. This is the content. If I click it's not okay, click is not okay and enter, it will still work perfectly. Our code is still work. That is, it's still working perfectly because this text, this is not okay. It's if I now change it to, let's say, 5 or 4, it will now, once it's not okay, it's there. Now it's okay. It's okay. You can also do the same thing for it's okay. Let us enter for it's okay. Text that contain is okay. What do you want to format it with? We are formatting it with, we want a green color, bold, and the field, we want the field to be, what color do we use? This light blue. And then the font we also want to underline, single line also. Then we click on OK. So now look at it here. Provision, it's okay. This thing is now green. So we can do this, not OK. Shh. You see that? And then OK. You see the color change and then underline. You can format it like that. The same thing, and the same thing for the flight 2, flight 3, and so on. Even to this deflection, you can also call this deflection. You can also call deflection somewhere here and also put the deflection there as you want to. So without wasting much time, let's quickly look at how do we compare this, our design with this textbook. Remember, we are using Engineer Victor Yonoga's design of staircase from his design from his textbook. And now we want to look at it. Let's look at the parameters. From the given parameters, we are asked to design a staircase, and we are designing it to, this is example. We are saying from the given parameter, the going is let's start with the going 275. The riser is 150. Okay. And what again? The finishing load we have 1.2. Okay. The waist of the stairs we are using 150. This is 150. And the stair is 1.5. The diameter of steel is 12. The cover is 20. The cover they are using is 20. You see that, and the beam they are using is 225. Okay. Now diameter of steel is 12. The step for 1 is 5. Step for flight 1 is 5. The first landing is 1,500. And the spacing we are going to, let's look at what spacing do we use. Let's see 200. Okay, 200, white over 200 works. Let's check their own, what do they use in their design. So white over 200, the area provided is 565. 566 is our own is 565. Okay, and the difference is an approximation anyway. The area of steel required, our own is 206, their own is 185. Okay, that is roughly on some of the variation in some of the parameters and convention approximation and all those things. Okay. Now, okay, this is 25. We are asked to use 25. Okay, let's look at it again. Okay. We are there. Alright. Now the next one is flight 2. Flight 2, what do they do? How many steps? The flight 3 has 8 steps. And we are still using 2 of this is 1,500. Okay, and you can say, okay, let's look at the spacing. 175. Okay, they are using 175 flight 3. Flight 3, 175, 646. Okay, 646. Okay, it's still okay. Provision is okay. The next flight is flight 4. Is 4 steps. Flight 2, 4 steps. And this is 1,500. And we are using Y16. Number of steps 4. Waist, let's use spacing, let's use 200. And then the waist, let's use 175. Deflection not okay, but this one is okay. Like 3 is okay. Provide was is at 200, 105. Provide was is at 200, 1005. Okay, but for the sake of deflection, we're going to increase it to 200. The waist at that point to 200 because of the load. So now look at it. We are true. How many minutes does it take? Less than 5 minutes. Once you have your parameters, we are true. This is provision is okay. Provision is okay. Provision okay. Deflection. Provision deflection is okay. So we are actually good to go. So this is how we design. You have this template. It makes your design very simple and very easy. You don't need to look for materials. You don't need to stress yourself. All you need to do, once you take your time and automate this and fine tune it, make sure it's okay. It doesn't take time. In less than 10 minutes, you are through with your design. irrespective how complex the staircase is. So I will be bringing other types of staircase and other designs of different panels so that you can see and you can use it. It's handy where you don't have a, even when you have a software to sit down and start modeling, like what I normally do with staircase. I don't use software to design staircase. I use my template, put in these parameters, and then go to the detailing and detail it as well. Pick this and only pick this value, pick this value, and pick this value. Then check deflection is okay. Okay, use a provision and the spacing and run my work, and it works perfectly. Thank you for your time, and I hope you enjoy this particular training. Make sure you like and subscribe, as we will be bringing many of these to us. We have a lot to do. I believe you want to come with us. We're bringing some interesting and live practicals like this. Maybe in one of my training, I will bring one of my live practical to show us how I've designed that using Excel to automate most of those things. Make sure you like and subscribe and comment if you have anything you notice in this work. Comment, we will review it and then let you know. Thank you very much for your time, and God bless.